Right now, part two of our unit test review for Unit 7 here is just going to be the application problems. And it looks like we start with pretty straightforward problem. You've just got a bowling ball rolling straight off of the top of the building. Yeah. So, I mean, if you wanted to draw it, you got building, height of building is 20 meters and 5 meters per second. So the question is, how far away does it land? So in the horizontal, our only factors are the initial velocity, 5 meters per second, times, well, in general, let's generalize these. You get, in the x direction, you get v sub 0 cosine of the angle that it is launched times t. And in the y direction, you would get the initial velocity times sine of your angle times t, plus the initial height and gravity. But for the velocity given, the 5 meters per second, if you are launching horizontally, as we are, off the side of a building, that angle is considered 0. So cosine of 0 is 1. So it's really the initial velocity, 5, times cosine 0, which is 1, so 5 times 1 times t. So we just get 5 times t. The y direction, we have, well, our initial velocity times sine of 0. Well, cosine of 0 is 1, sine of 0 is 0. So this whole term, v0 sine 0 t, that just all goes away because it's just 0. So that term is null and void. But the other two things we're accounting for is the initial height. So h sub 0 is 20. And our gravity constant. So there's three terms vertically. There's gravity, initial height, and potentially an initial velocity. Gravity in this case, we use the term negative 4.9 t squared to represent the position after so much time after gravity has affected it. So we have our two equations. In the x direction, we can figure out how far we've gone based on our time. And the same thing here with our y direction. We know how far it's dropped based on time. So in order to find the time nearest to a tenth of a second, we don't know how far away it landed. So we can't say what x is per se, but we know that eventually y becomes 0. So we can set y to be 0 and say that's equal to 20 minus 4.9 t squared. But what we can do is if we solve for t here, we know how long it took to get to 0.0. So 20 equals 4.9 t squared because we just added that to both sides. And when you divide by 4.9 on both sides, you get t squared by itself. Then you take the square root of your answer. And in the end, you get t is equal to 2.02 seconds. So to the nearest tenth of a second, your time is 2.0 seconds. But see, as long as we know that it took 2 seconds to fall vertically, we know that that's the same amount of time that we were traveling horizontally. So we can apply that 2 seconds to our x equation and come to the conclusion that we also traveled 10.0 meters to the nearest meter, 10 meters from the building. That's the easy setups. It's traveling straight off, horizontally off of a building or a structure. Let's look at our next one, number 6. Number 6, we've got a ski jump that has an angle. So these get a little more tricky. So again, our general equations in the x, it's going to be our initial velocity, so 17.9 times cosine of our angle. 3. And then that's times t. So we don't get a nice round 1, so we have to leave it as cosine of 14.3 degrees. Then, in the y direction, we do have 17.9 sine of our angle times t minus gravity minus 4.9 t squared. And does it say how high the ramp is? It does, right here. So plus 1.71 meters. So this one here, we can't just move one t term across like we did for the first problem. See, in this problem here, we just said, well, if we just move the one term over and solve for t, then we're okay. We have a t squared, a t, and a constant term in our y direction. So we have way too many variables to just solve this quickly in our head. One way to do it, though, we do have an algebraic quadratic formula. We have ax squared plus bx plus c. So using quadratic formula, our quadratic equation, I should say, that we have here can be solved using the quadratic formula. But what I would say is when you have a problem like that where if you plug in 0 for y and you still have too many variables, what we're going to do is we're just going to use the graph. I'm just going to say use graph find equals 0. So we're going to look for that point where, use this t value. Okay. So we're going to use this t value on our graph to figure out where the heck we get our information for our time and our distance. So let's just plug this into a calculator and see what happens. So we're going to go to actually, I'm going to pause just to enter it, just to save some video time. Okay, so here it is. Just make sure you get everything plugged in correctly. My window, I'm just going to talk about. Time is our t value, so we don't need anything before 0. And it should take less than 10 seconds of airtime. Leaving t-step 0.1, again, x min is 0 because that's kind of our starting point. We don't need to look backwards in distance, and we don't need to look below ground. So our y min and x min, they're both 0. I also don't foresee this skier going more than 50 feet past the ramp. That's plenty. And in terms of height, they hit the ramp at almost not even 2 meters off the ground. They should not go higher than 10 meters off the ground. So these are, again, just using common sense or real life, what's going on in the problem. Set it up, and I'm going to hit graph. And so I was right. I mean, I'm within it. I exaggerated a little bit too, but I'm going to trace that and see. It is asking for, it says time, the nearest tenth of a second. So nearest tenth of a second is only going to be like 1.1, about 1.1, 1.2 seconds puts us, actually 1.2 seconds is really close. So I'm going to go back and I'm going to say time that it took us was about 1.2 seconds. The distance from the ramp, let's go here. Distance from the ramp was about 20.8. It does say to the nearest meter. So I'm going to round. Again, this x distance is the skier. They come off the jump, they go up a little bit before they come back down, and then they hit the water. So about 21 meters later. So distance about 21 meters. And that's it. There's in terms of the math, we're not going to solve these. We don't need to. We don't really have the time to. So that would be it. I'm pausing this video now. I'll do 7 and 8 in another video.